Imagine a cosmic traveler, 3I Atlas, zipping through our solar system, leaving behind a trail of mysteries and wonder. This interstellar visitor has been making headlines, and for good reason. It's providing a treasure trove of unique scientific data that researchers are eager to unravel. A recent pre-release paper from the Auburn University Department of Physics sheds light on yet another fascinating aspect of 3I Atlas, its water content. Water is one of the most abundant substances in the universe, even though it's scarce on many planets in our solar system. Most comets carry some water, which forms a cloud of water particles, or coma, as they approach the sun. This cloud heats up, turning into water vapor that streams behind the comet, creating its iconic tail. But 3I Atlas is breaking the mold. When it was first spotted, it was about 6 AU from the sun, and it's been steadily moving closer, with its closest approach expected to be around 1.3 AU in October. In late July, when the comet was about 3.5 AU from the sun, astronomers from Auburn University used the Ultraviolet Optical Telescope, UVOT, on the Neil Gehrels Swift Observatory to study it. This telescope, orbiting above Earth, is particularly adept at detecting faint photometric lines, including those from water. Typically, astronomers wouldn't expect to see OH, hydroxyl emissions, which are used as a proxy for water, so far from the sun. The process of water ice sublimation isn't very effective at that distance. But to their surprise, the researchers found a strong OH signal and no sign of cyanogen radical, CN emissions, which are usually one of the first signals detected on a comet. This absence of CN could indicate that 3I Atlas has a composition that's quite different from the comets we're familiar with in our solar system. The study also provided an estimate of the comet's active surface area, the portion of its surface that's actively producing water vapor. The researchers calculated that about 19 kilometers square of 3I Atlas's surface is actively producing water. Given that the comet's diameter is estimated to be no more than 2.8 kilometers, this means that around 20% of its surface is actively producing water vapor. This is significantly higher than the typical 3 to 5% for comets in our solar system, which could be due to the fact that 3I Atlas is likely visiting a star for the first time, giving it more water to expel. This high water content is crucial for the next steps in observing 3I Atlas. The researchers have proposed 2 hypotheses that can be tested as the comet reaches its closest point to the sun. If water production peaks near perihelion, and only trace amounts of high metallicity volatiles like carbon monoxide and cyanogen are detected, it would suggest that 3I Atlas originated in a low metallicity system, one dominated by hydrogen, with few other elements. On the other hand, if water production drops off significantly after perihelion and is replaced by increased volatile production, it would indicate that 3I Atlas came from a high metallicity system, similar to the last interstellar visitor, 2I Borisov. Given the intense interest from both scientists and the public, 3I Atlas will be closely monitored over the coming months while it remains visible. With new hypotheses to test, this interstellar visitor will continue to expand our understanding of its origins as it continues to melt and reveal its secrets. The world will be watching as it does. Learn more. Zhang et al. Water detection in the interstellar object 3I Atlas. https://archive.org/pdf/2508.0475/UT Gemini North Seas Brightening Interstellar Comet 3I Atlas in detail. https://www.universetoday.com/article/Gemini North Seas Brightening Interstellar Comet 3I Atlas in detail. www.universetoday.com/articles/newly discovered interstellar comet is billions of years older than the solar system. UT Hubble captures stunning view of third interstellar visitor. https://www.universetoday.com/articles. Hubble captures stunning view of third interstellar visitor.